Hi, everyone. My name is Daniel Moyer. I'm one of the sales support trainers here at Briggs & Stratton Energy Solutions. Welcome. Today, we're going to be talking about energy storage systems in harsh environments, mainly cold weather, but we'll talk about hot weather and humid weather as well. Just to get started, the chat has been disabled, but the Q&A is open. So please put any of your questions in there and we'll address them as we go along, or at the end, we'll check to see if there's any we've missed. Additionally, this course is approved for NABCEP credits, so we will be issuing continuing education NABCEP credits. At the end of this talk, my email will pop up. We'll go ahead and email me your full name. I'll check the records, and then we'll go ahead and issue you the credits after completion of the webinar. So I went back and found this in the Briggs & Stratton archives. So cold weather is not new to us. Winter is coming. And we want to be careful that we treat our batteries carefully in cold weather. And we're going to talk about why here in a second. But I found this photo here. This is a snowmobile, and I'm pretty sure this is in between World War I and World War II. And you can see the Briggs & Stratton engine here. So it was pretty interesting. I'm excited to work for Briggs & Stratton. We have such a long legacy, and knowing that there's a lot of competition out there in the energy storage battery marketplace, it's nice to be working for a company that's been around for a long time, that's going to be around for a long time, to support the warranties that may come up. We now offer a 15-year warranty on our stacking 6.6 battery. We continue to offer a 15-year warranty on our amplified 3.8. So just knowing that we have such a long legacy and history is exciting to know we're here to help you when the time comes, and we're not going anywhere. Another exciting event always is NABCEP. The North American Board of Certified Energy Practitioners is having their conference. It's going to be in Milwaukee. So if you're ready for some cold weather, please come on out to Milwaukee in March. The QR code on your screen is to register. At Briggs & Stratton headquarters, we're going to be hosting an event on Monday, the day before the conference starts on Tuesday. I would invite you to be our guest. We're going to have some trainings, some tours of our museum, so you can go check out that snowmobile, as well as some of the other products that Briggs has made over the past 117 years. The conference goes Tuesday, Wednesday, Thursday. Again, if you want to attend our pre-event party, go ahead and email me. My email is going to pop up at the end, and I'll make sure you get an invite to that. We've been partnering with SolarC for quite a while, and there's some exciting news with SolarC. They just released their SolarC 18K at the RE Plus show, which was about 3 weeks ago now. 18K is by far the most powerful residential hybrid inverter on the market. It can do 18,000 watts from batteries to loads. It can surge up to 36,000 watts. That's 150 amps AC at 240 volt. So we continue to be partners with SolarC. They're one of the first companies on the market to come with a hybrid inverter. They're an American company. We're an American company with American-based tech support and resources as well. Another new exciting announcement, though, is our partnership with EG4. This was also announced at RE+. EG4 makes very similar hybrid inverters, right? The 12K PV, the 18K PV that you see on the screen, but they also make a FlexBoss GridBoss combination. And stay tuned for upcoming webinars on our partnership with EG4. EG4 out of the box inverters are EMP hardened. EG4 can also provide that GridBoss FlexBoss combination, which really in a way decouples where the inverter and the service needs to be as service entrance. So stay tuned on that. Exciting to offer the partnership. What does a partnership mean for us here at Briggs & Stratton? It means that we've not only tested and validated that our batteries and their inverters will work, but we're also ready to support you as the installer to do these integrations with integration guides, with training from our tech support to help you if you do have any issues, and the ability to offer sales collateral so that when we're sitting down at the kitchen table with the homeowner, we're able to present products in a nice format on these printed documents as well as digital resources. If you want any of that, let me know and I'll be happy to provide it to you as well. So as we talk a little bit about cold weather, we get into it. Lithium ion batteries of any manufacturer have a tough time in cold weather. So as we look at the screen on the right-hand side here, the lithium likes to follow its electron. So when we're charging up a battery, we're going to pump those electrons from the cathode side over to the anode side. And the lithium ions like to follow their electrons. And they're going to migrate through the liquid electrolyte and start to embed themselves into the anode layer. So when we have cold weather, that liquid electrolyte can become viscous or thick like molasses, and that can kind of impede the migration of the lithium ions over to that anode side. It can slow down the charge rate, and if it gets really cold, it can actually prevent the lithium ions from kind of making its way into the anode. And what can eventually happen is dendrites or crystals can start to form there. And if it continues, it can actually puncture the cell and cause a short circuit. At the very least, it's going to reduce the ability to store energy in that battery cell. So sometimes this can be temporary and sometimes it can be permanent if we damage the battery through that dendrite growth. So it's important that we do things to mitigate this effect. Some of the ways we can mitigate this, and we've done this in our 6.6 Simplify battery, is we've optimized that electrolyte so that it doesn't become as thick in cold weather. That allows us to operate our 6.6 stacking battery down to 14 degrees Fahrenheit without the need of heaters. Of course, if it continues to get too cold, we're going to want to look at heaters, and we have those available on our Phi and Amplify battery. Another way we can mitigate the effects is by having the battery and the inverter talk to each other. And the battery, which is monitoring its temperature, knows when it's starting to get cold, and we can reduce the charge rate, the C rate, so that we don't damage the battery. And as we slow down that charge rate, we're going to prevent those dendrites from forming. We're going to allow that battery, which has an internal resistance, to warm itself up and allow those lithium ions to migrate more freely as well. So that's a really interesting concept, is the ability to go to some of these cold weather temperatures without the need of heaters. Heaters create hot spots in the batteries. Heaters are also a parasitic load that are draining the battery to then warm the battery up. Now, we talked a little bit about charging, right? The cold weather prevents the dendrites or the lithium ions from flowing and can cause the dendrites and can prevent that lithium ions from getting to where they need to be. Now, on the discharge side, we usually hear that discharging is not really affected by cold weather. It can, though. And what we're looking at here is an example of some lithium iron phosphate cells that are submerged in a temperature cooled bath. So they're being kept cold. And what we see here is some discharge profile. So down at the bottom, we have the depth of discharge, right? So over here is a full battery. Over here is a completely discharged battery. And then on the y-axis, we have the voltage range. So if we see we got some warm batteries over here, a 20 degrees centigrade is maybe what, 70 degrees Fahrenheit. And if we start to discharge the battery, we got that flat curve that we expect with the lithium ion kind of profile, and then we drop off. What I'm demonstrating here, though, is as temperature gets colder, we have a low battery cutout voltage, all right? So we don't want to discharge the battery below 48 volts. But as we're discharging batteries in cold weather, let's look, for example, here at 10 degrees centigrade, that we drop below 48 volts when the battery is only about, let's just call it halfway discharged. So the point of this chart here in this graph is to demonstrate that while discharging a lithium ion battery in cold temperatures, we get less capacity and it can be affected by the cold temperatures. Now, this is in a temperature controlled bath. In a real life example, the battery would kind of warm itself up as we're discharging it due to the internal resistance. But it just goes to show you that charging batteries in cold weather can be affected and can cause loss of capacity and even damage to the battery. And discharging lithium ion batteries in cold weather can also cause loss of capacity. Now, there are different types of form factors, cylindrical, pouch, and prismatics, and they all have their different strengths and weaknesses. But I just, again, wanted to show the example of the inside of the cell. They all kind of have this similar type of cathode, this liquid electrolyte, inorganic electrolyte, and then this graphite layer. And as we pump the electrons over here, the lithium ions will flow over to this side. And then as we discharge, we can put a load here, not a charger. The electrons are going to flow to the other side. So when we think about cold weather, I mentioned 14 degrees Fahrenheit. That's not necessarily ambient temperature. As I kind of hinted at earlier, batteries have an internal resistance and warm themselves up under charge and discharge cycles. And also kind of look at that picture that we see on the right-hand side. Well, one, those solar modules are tilted pretty steep to capture that winter sun that's probably pretty low in the horizon. And then realizing that our power shack or our power shed over here is most likely insulated. And although the outside temperature may be 0 degrees or 10 degrees Fahrenheit, the inside of that shed is probably not ambient, especially if we have inverters in there that are processing solar that are going to warm up that building. So thinking about the internal temperature of the battery is, when I say 14 degrees, not necessarily ambient. And we have embedded thermistors inside of the batteries in between the cells. So we're measuring the battery temperature, not necessarily ambient temperature, when we make the decision to curtail charge or at some point even stop charging altogether because the battery got too cold. Just to reiterate, right, loss of capacity at temperatures below freezing. You can reduce the cycle life or damage the battery if you continue to charge under freezing temperatures. And you could even potentially damage and void your warranty if you continue to charge in freezing temperatures. So let's jump into a little bit of the products here and talk about one of the concepts, that charge rate reduction can help prolong the battery life in low temperatures. So we have a Phi battery, and our Phi battery is either 24 or 48 volts. It's 3.8 kilowatt hours. And that battery does not have closed loop communications. And that can be a great option for an older system like lead acid battery replacement, where they don't have a communicating system. Maybe they got an old Schneider or an old Xantrax inverter and some old charge controllers. So let's go ahead and not leverage a closed loop communication system. But that problem with that is that the Phi battery can't communicate to an inverter that it's getting cold and reduce its charge rate. Whereas our Amplify and our Simplify 6.6 do have communicating battery management systems that can automatically reduce the charge rate based on the temperature. And at some point, if the temperature continues to drop, the battery will even disconnect itself, preventing that voiding of the warranty, preventing damage to the battery. So making sure that our communications are set up properly, needs to be part of our commissioning process. And as I mentioned, we have integration guides that allow us to do that and make sure that they're vetted and working. You can see on the right-hand side kind of the chart that demonstrates the charge rate reduction example. So we're not going to cut it off right as we get cold, but we're going to slowly ramp it down. And at some point, we will eventually completely cut it off. I'm really excited about our 6.6 stacking battery. We've had amazing success with this battery, It goes together quickly. It's really engineered and designed for the North American market. It has a 2-inch knockout because we understand that here in the United States, we use conduit. We've designed the wall mount to be able to go onto wood stud walls, either wall mount or floor mount. But in the context of today's talk, I want to bring our attention down to the charge temperature, that 14 degrees Fahrenheit that can be charge the battery without the need of heaters. Discharge, absolutely, we can get a little bit lower down to -4 Fahrenheit. Another thing I want to talk about here is our warranty. We have that 15-year warranty, but it's a 100% depth of discharge with no cycle life limitations and no throughput clause, a straight 15-year warranty. That being said, we do have some estimated cycle life based on the rate at which you charge or discharge the battery. So at a C/2, right, you charge the battery in 2 hours or discharge the battery in 2 hours, we expect 6,000 cycles. 6,000 divided by 365 is about 16 years. Now, if we charged or discharged the battery a little quicker, an hour and 15 minutes, which is our 0.75 C rate, we're expecting about 4,500 cycles. And I think that's an opportunity here to talk about batteries and the way they're going to fit into our marketplace. You know, batteries provide backup, they provide resiliency, but batteries can also be what I like to call a grid interactive appliance. They're meant to be cycled. They're meant to do time of use arbitrage. They're meant to shave off peak demand. They're meant to also store solar when we can't feed it back to the grid in states that don't have net metering. They're meant to work for you in your home to provide that resiliency, to provide that distributed asset that our electrical grid needs as we start to put more demands on the grid. Last thing I want to call to your attention is the humidity, and we'll get to that here in a second. So we're looking at Solarc down in the bottom left corner, and we're looking at the charge rate of the battery. Now, what we're seeing here on the right-hand side is right out of our manual, and it's the rate at which you can charge and discharge the battery based on the number of battery modules you have. Now, that number is going to be variable as the temperature changes. Looking at that Phi battery, the Phi battery, remember, doesn't have that closed loop communications and cannot curtail its charge rate. So we're going to recommend is don't let that Phi battery get any colder than 32 degrees or 0 Celsius, right? Don't let that battery get below freezing temperatures. That's where battery warmers are going to come into play. And I'll show an example of that here in a second. But with the Amplify battery, the one that can communicate, we can go below 32 degrees Fahrenheit, but we're going to start to curtail our charge rate. What's really exciting about that Simplify 6.6 stacking battery is that we can go down to 14 degrees Fahrenheit without having to curtail any charge rate. Keep in mind, the Phi is a great battery, especially for lead acid battery replacements, but we're going to want to leverage heaters on that. Whereas the Amplify does have that more advanced temperature control that can communicate with the inverter to tell the inverter it's cold. And at some point, if it continues to get cold, the Amplify will simply open up its contactor to protect itself. So there, in a lot of ways, there's 2 levels of protection. Going back to the 6.6, I still like that there's a battery status LED indicator up top to show you the state of charge. You know, we're so reliant on these apps and the ability with My Solarc or EG4 app or any of the other ones. And we do have our own energy track, but the idea that we still have an indicator up top to show that homeowner that maybe doesn't like to interact with a phone or a computer to show what their state of charge is. Down in the bottom left corner of each battery module is an indicator light to show that it's on and functioning properly. And each battery stacks together seamlessly using a rapid stack connector, not only the power, but also the communications. Each of the battery modules, you can do up to 3 modules in a single stack. are all held together by alignment pins. And then where there's little screws, M10 screws that are going to hold the whole stack together. You know, we in the industry in the energy home standby market really leverage lithium iron phosphate. It's been kind of the chemistry of choice for a while now, and it wasn't always that way. Simplify Power, before the acquisition by Briggs, was really one of the pioneers of using lithium iron phosphate, LFP. LFP has a much longer cycle life. LFP also can be, I would say, a little safer. Now, I want to be a little careful in my language there, that absolutely lithium iron phosphate is a safer chemistry, but the safety profile of a battery shouldn't be based solely on the chemistry being leveraged. In fact, Briggs and Stratton has an entire Vanguard battery line where we have cobalt-based batteries that are used in lawnmowers, riding lawnmowers, and other equipment like concrete smoothers and light towers. In those applications where energy density and having it be lightweight and probably a quicker charge and discharge rate, cobalt is a better chemistry. And what really makes a safe battery is going to be the form factor, whether it's a cylindrical, prismatic, or a pouch cell, the battery management system to protect it, the vents, and also the construction of the battery itself and how those cells are put together. So absolutely, we do use lithium iron phosphate here in our standby batteries, but keep in mind, Briggs and Stratton, a very large company, also is experts in cobalt-based chemistry on our Vanguard line. I love marketing photos. You can tell this is a marketing photo on the left-hand side. It looks great. Some things I'm not seeing are all the stickers from PV labels that you probably have to put onto them. I'm not seeing any conduit going from solar or to loads. But keep in mind, I think the point of this picture, though, is it looks good. And I think looks do matter. We as installers go out there and install a battery and run back to our truck and get on to the next job. Whereas a homeowner has to look at this thing for 15 years, 15 plus years. So having looks matter, and knowing that we can also do a wall mount, I think really matters to a lot of the homeowners. It is indoor or outdoor rated. The batteries can be also, I would say, probably put indoors if we're going to be in really cold ambient temperatures. I'm thinking of like Wisconsin. I'm thinking of Montana's Maine. So although they can go outdoor, if you are in a really cold temperature, I like the idea of putting them in garages. A garage is going to usually be a little bit warmer than ambient because the garages usually have a shared wall with a home. So we're getting some heat leaking from the home into the garage, although they usually are insulated. That's going to keep that garage a little bit warmer. Also, having it covered, we're going to reduce any sort of nighttime radiation loss, right? So we can either lose heat through conduction, convection, or radiation. So if we have it in a garage, we're not having a cold wind blowing across it. That's convection, right? If we're keeping it in a garage and we have some heat leaking in through the home, we're not losing anything through conduction. And if we have it covered in a garage, we're not losing any heat through radiation at nighttime. So we can definitely put it indoors. Keep in mind, your local building and fire codes are going to state that you can't put it in a habitable space in a home, but a garage, a basement, a utility closet that has a door to the outside are usually going to be okay. Make sure you check with your AHJ. So if we're not able to put it in a garage, one option is to put our batteries outside. And we have some cabinets. The Boss 6 cabinet on the left can hold 6 Phi or amplified batteries. The Boss 12 in the middle is up to 12. And then we have what's known as the Access cabinet. An Access cabinet can have 6 batteries down below and an inverter, a solar 12K inverter up top. And The idea here is if we do have an inverter up top, right, that inverter is going to be generating heat, especially if it's processing a lot of solar. And we can also insulate this cabinet as well to keep it warm and make sure we keep that heat in there. And that kind of brings up my next point is, right, cold weather temperature affects battery on the charge cycle. Usually when we're charging batteries, it's during the daytime when solar is charging the batteries. So I know it gets really cold, and I think if you put into the chat, what's your coldest ambient you've had during the day, it's probably going to be colder than 14. But the idea is that during the day, ambient is usually a little bit colder, warmer than it would be at night, and that's usually when we're going to be charging our batteries. Just keep in mind if you're ever going to do these. I like the way we do sell bus bars, and remember what we're going to do with our bus bars is our positive is going to be over here. Our negative is going to be down here on the opposite corner. So we're feeding the battery bank equally. So insulation, right? We can't insulate the cabinets or even a structure so that we're trying to keep the heat contained within that structure. You can also put, I would argue, to put insulation on the bottom of those batteries so they're not touching that cold metal shelf, and then also insulate the walls of the battery as well. The inverter, the charge controller are going to generate some heat, and if it gets too cold, right, the batteries are going to communicate to the inverter to reduce its charge rate, and at some point it's even going to shut itself off. Measuring ambient temperature isn't really going to help us. What we want to do is to be able to measure internal cell temperature and make decisions based on that rather than ambient. And one way we do that is if you are going to have heaters for our batteries, you need to specify that at time of ordering. And what we do in the factory is we embed a thermistor in between the cell packs. This little gray plug right here is going into that. I believe it's a 10K thermistor. This is going into that thermistor. And then on the bottom of the battery is the heating pad itself. So we put the heater on the bottom of the battery because if you were to open this battery up, and don't do that because you would void your warranty, you would see all of the cylindrical cells in that battery are kind of in stacks. And by heating the bottom of the battery, we get better thermal conductivity through the cell packs by heating the bottom of the battery. Again, I would recommend putting insulation on the shelf of the battery so the metal case of the battery isn't touching the metal shelf, which is going to kind of suck the heat out of the battery. So again, keep in mind that the battery heaters need to be specified at time of ordering, and the battery pads themselves are about 75 watts per battery. Now they cycle on and off, right? They're not going to be on constantly. It's going to be a function of ambient temperature and how well insulated that cabinet is. But if I do, 75 times maybe 6 batteries, that's 450 watts. That if all those battery heaters come on, that's not insignificant. And a lot of other battery manufacturers have heaters built into them. And from what I've heard, a lot of them are larger than 75 watts. So it's not insignificant the amount of power required to heat a battery in cold temperatures. That's why it's really exciting that here at Briggs & Stratton, we've able to optimize the electrolyte in that 6.6 stacking battery so we can go down to 14 degrees internal temperature of the battery without the need of heaters. The heating pads are all controlled by relays. This will all be pre-wired if you order it with one of the Boss cabinets. So we're not only feeding the thermistors up here to these thermostats to tell the thermostat when to turn on and off, but we're also feeding power out of the thermostats down to those heaters. Those heaters that we use are AC heaters, so we're actually going to feed power from the inverter output to this DIN rail that has these thermostats on it to turn on and off those heaters based on internal cell temperature. Now, if you don't have that, there are some other products available on the market. Victron, notably, makes the BMV 712, and when that's integrated with one of their charge controllers, the charge controller can reduce its charge rate based on temperature. Keep in mind that it's not an internal temperature sensor. This is what it looks like here. So I would recommend, sandwiching that sensor in between two batteries so that we're getting as close to ambient temperature, internal cell temperature as possible, without physically having a built-in thermistor inside of the battery. So that's cold weather. Let's talk a little bit about hot weather. Um, it definitely can be an issue with batteries. One thing we can do is, charge up to a certain temperature, and then again, if it gets too hot, um, what we're going to want to do is stop that charging. Now, all of these concepts that mentioning about the batteries also affect the inverters and the charge controllers and the other components that are connected to the system as well. So we can, and I have seen this, use a mini split to keep a battery compartment or a battery structure cool as well. But if it starts to get too hot, what we're going to see is the breakdown of the electrolyte. And again, what we also want to see is that we use the protections built into these systems to prevent the batteries from being charged at too warm a temperatures. I'm looking here at this picture of a desert here as well. And the other concept that I want to mention also is humidity. So humidity itself really doesn't prevent too much problems for the batteries. They're all sealed up pretty well. What can happen though is when you have humidity with salt spray or salt, or even I would say like this pool you see here with chlorine as well. So what that can happen is the battery terminals up top can start to corrode, and eventually it can cause some more resistance in some of the conductors. So if you read our warranty carefully, it says to limit exposure to corrosive salt air, outdoor installations must not be within half a mile of a saltwater body, so the ocean. If you do put it within a half a mile, you're going to want to put it inside a garage, inside a basement, inside a structure like a battery shed or something like that. Because if you put it outside, it can void your warranty. It will void your warranty if we keep it outside within half a mile of the ocean. Altitude is another one to keep in mind. Well, first off, it's colder at higher elevations. For every 1,000 feet of elevation you go up, it gets colder. So it's going to be necessary to look at those heaters, but also there's less air pressure. And what that can mean is that certain cell form factors are impacted more by this. So a cylindrical cell is a cylinder, right? Inherently it has a lot of strength to it. So being a cylindrical cell, inner amplify batteries, it has really no altitude limitation. Cylindrical cells are also tend to be a little bit more safer in some of the 9540A test reports. Cylindrical cells, though, can take up more space because if we have a square box and we're putting these little round devices in there, there's a lot of air gaps. So cylindrical cells absolutely have their benefits, whereas prismatic cells, right, they also tend to be a little bit larger form factor. They're not quite as rigid. They also tend to have a larger cell volume. So if there is a thermal event, you get more gas coming out of it. But pouch cells, pouch cells, which is what we used in our Simplify 6.6, what that allows us to do is have a really dense battery. We use a blade type pouch cell, and we're able to compress them physically in there. And it allows to really pack in a lot of energy in a very small form factor. So being a pouch cell, though, as we're talking about here on the right-hand side, as we go up in altitude, there's less pressure, atmospheric pressure, to kind of keep everything together. So if you look carefully in our spec sheets, right, the Phi and the Amplify battery, we're down at the bottom there at altitude limit, has no directional operational limit, no direct, right? It can be on Mount Everest, I suppose. Whereas the Simplify 6.6, we see in our literature 3,000 meters or 9,800 feet. Now, if you go look in the inverter instructions and spec sheets, it's notable that the Solar 18K, and I was just checking this yesterday for this deck, they say they can go up to 3,000 meters as well. Whereas the Solar 15K and 12K can go up to 2,000 meters, but they start to derate above that. I checked out the EG4 inverters, and they were specifying 2,000 meters. So I want to pause and just ask everybody on the call, what's the highest altitude you've done an install at? And do you see for your market that doing installs above 9,800 feet is going to be a problem for you? Put it in there. Whoever, I'm going to do the honor system, but whoever can give me the highest altitude that they've done an install at, I will go ahead and get you a Briggs & Stratton Lego kit. So again, question is what's the highest altitude you have ever done an install? Maybe give the location on our system, and whoever gets the highest install, I'll go ahead and send a kit to you. So go ahead and put that into the Q&A now. Another consideration, though, is vibration. So the and that's a great looking Airstream. I suppose those solar modules are going to want to fold. I'm sure they fold down when you're traveling, but we see this more and more often. Is these, especially I thought after COVID, everybody wanted to buy an RV. Victron, makes some amazing products for the RV market, and we're seeing more and more RV installs wanting to leverage lithium-ion battery chemistries and not the lead acid. Right? They're lighter weight, they're more energy dense, but you can have some issues when we're traveling down the road and it's bouncing up and down. Well, we've had a long history of mobile applications. Our batteries initially were used in forward operating bases in places like Afghanistan for the military, where we understand and constructed those batteries to be very robust. So when we think about where we're going to put those batteries, though, keep in mind, I like the idea of positioning the batteries underneath some insulation, which is going to provide some shock absorption. Maybe also try to position them under the axle so we're not getting as much bouncing if we were on the back or the front of the trailer as well. So enough theory. Let's take a look at some real installs. This is a great example here. One thing I wanted to mention is here's some Boss 12 cabinets. Boss 12 cabinets are rated for outdoors, but you have to specify that you want these rain hoods. So there are vents on these Boss cabinets that have thermostatically controlled vent fans. So if you are going to put a Boss cabinet outdoors, let's make sure that we have the rain covers. Those are an optional item. They're not very much. So we have 4 Boss cabinets, all full of battery. We have a Boss 6 cabinet here that has 6 more additional batteries. And then this guy right here is actually not a Boss 6. This is our 2,000 amp battery combiner. So if you were to open that up, you wouldn't see any batteries. You just see some giant copper plates that are combining up all of these batteries and then sending that DC 48 volt nominal batteries voltage out to these inverters. And I believe this is a commercial three-phase system here, and these all look like solar 12Ks. So inside of each one of these batteries, cabinets are the battery warmers, and we're able to use the AC output to keep these batteries warm when it gets cold enough. Again, they're on thermostats, so it's not like we're running the batteries all day. Now, I would imagine when we see it sunny here, those batteries are being charged. And when a battery is being charged, there's some internal resistance, which is going to keep it warm. Gail's asking, uh, slides not charging. Not sure what you mean by that. Gail, maybe I misspoke. Please go ahead and type in your question again. You know, I mentioned the history of Briggs and Stratton, but I don't think I spent enough time talking about the history of Simplify Power. So Briggs and Stratton acquired Simplify Power about 3-4 years ago now. But Simplify Power has been around for over 15 years. And in the energy storage industry, that's, especially the lithium ion side, that's a long time. The Tesla Powerwall 1 didn't even come out until 2015. That was just 10 years ago. So we've been making these lithium ion batteries for a long time. Initially, we got started in the film and broadcast industry. We make the batteries out in Oxnard, California, which is next to Hollywood. And then additionally, we've been moved into the DoD marketplace, and then we moved into the home storage. What you're seeing in that top left corner are some of our older Simplify Phi batteries that still have the ABS plastic case. And we're looking at a cabin out in Montana. And what they did is they put the batteries inside of an insulated cabinet here. So you can see the styrofoam insulation. They even put some foil here to prevent some radiation loss as well. And then we're feeding up to some old Schneider equipment. I like the ground mount system, and kind of just to give you an example of how cold it is there out in Montana. Right, there's probably a black bear here with some mountains in the background. I like that they have a thermometer up here to kind of keep eye on things. There's another off-grid example up in Alaska. So this has happened probably a few years after that last install, because we've transitioned to our metal Phi cases, still with the old Simplify logo on them. And what I want to point out here is this heater here. That's a propane heater. I can see the little propane line. And of course, it has a little AC outlet to run the thermostat, the igniter for that propane heater, and probably also to run, there's almost certainly a fan blowing across that burner in there. But it's probably set to maybe 36, 38 degrees Fahrenheit. We don't need to keep this whole room nice and toasty, but we want to keep it warm enough so that we can prevent those batteries from getting too cold where they would get damaged in cold weather. I really like the bussing here. That looks really nice. And then up in the top right corner are some nice pole mounts. Again, those panels looks like they're tilted pretty steep to capture some of that sun that's pretty low in the horizon. They may or may not have single axis tracker where we can tilt them a little less steep in the summer to capture some more of that summer sun. Talked about mobile applications. Right here, we got our Phi batteries in a food truck. Oregon, Portland loves their food trucks, if you can imagine. If you've ever been there, you can imagine that. I do like some insulation down here below to prevent vibration. I like this big aluminum bar here to keep everything nice and secure so our batteries aren't going anywhere. I do like the solar modules. This is pretty slick, right? We got some solar modules that are fixed, and then it looks as though there are some solar modules on a track that can kind of track out. And then if anything, give a little bit of an overhang for your customers down below, but then also provide extra power. Um, One thing I kind of like here is I can see our negative up here going up, and it looks like our positive over here is coming up. But I don't like that they used conductors to run these batteries in parallel. I would have rather seen a bus bar. And if you look at the the amount of metal or the cross section of our bus bars, it's pretty thick. So we're gonna get better discharge and charge um, kind of balancing if we were to use bus bars in this example. Here, with why we're tapping off here and we're double legging here coming off, there's resistance that's being built up as we kind of come across to this last battery. So, in a lot of ways, this first and this last battery are going to be working the hardest where this middle one's not. Not bad, but I would have liked to see bus bars or like maybe a Victron links power in here and it had all the batteries with equal length wires feeding into a combiner here and then coming out of the combiner up to the inverter, which is somewhere else in the truck. Heat, right? The idea that we're going to have heat, again, making sure that we insulate the structures. I can see a lot of our Phi batteries here. This, I think, is a Midnight Solar combiner here. It may or may not be because I can see all the battery cables coming in here. Looks like a lot of Outback charge controllers and some Outback Radiant inverters here. They may or may not have air conditioning in this structure. So this is a picture of our facility down in Oxnard. So we vet and test our batteries in our labs here in Oxnard, but we also send our batteries out to third-party testing, right? We're going to send them out to Nerdles for our 1973 UL 9540, and then also additionally our 9540A large-scale fire testing. So 1642 UL is our cell, 1973 is our battery level, and then the UL 9540 isn't necessarily a test, it's a certification on the system level. And we do have a DC ESS UL 9540 on our Simplify 6.6 stacking battery. Remember, that's the one that can go down to 14 degrees Fahrenheit. What that means is that by having a DC ESS UL 9540, we can partner with any inverter that has the UL certification on the battery on the inverter side. 1741, right? UL 1741 is on the inverter. We have DC ESS 9540. That means we can partner together with that EG4. We can partner together with that Solarc. And as long as those two components have that, we're good to go. The UL 9540A is also on the Boss cabinet and with the Solarc 12K, the access cabinet with the Solarc 12K up above. So outside of those UL tests, which are pretty impressive if you ever want to actually look at the results, no flames observed, very little gas venting. Another test we have to go through is our being able to ship these things, and that's UN 38.3. So what we do is in order to ship them, we have to, one, only ship the batteries at a 30% state of charge, but then also get this stamp on it. And we send these out and they do some tests. What do, right? So one thing is that they store the batteries at a very low pressure. So that kind of simulates being in the cargo hold of an aircraft. Likewise, it would simulate it being up on top of a mountain. They thermally cycle the battery so that, as we're on the ground, it's warm. When we get up to altitude in an airplane, it cools off. And then when we get back down, right, where there's rapid thermal changes there, and they simulate that. They vibrate it, and they also impact it, right? It's subjected to shocks. So in order to pass, which we did, these tests, there has to be no leakage, venting, disassembly, right? It can't fall apart, no rupture and no fire. And then, right, the open circuit of each battery directly after testing is not less than 90% of its voltage prior. And lithium ion batteries in general hold their state of charge very well. So we pass that. We continue on to some other tests. They basically, short circuit, right, the battery. And then first they heat it and then they short circuit it and see what happens, right? It must not exceed 170 degrees Celsius and it must not catch fire to pass. And then they overcharge it and it must not catch fire. So these are tests. If anybody has seen other batteries, right, that have this stamp, these are the tests that they have to be subjected to. So we're going to quickly talk about batteries. We only have about 10 minutes left, so I want to make sure I leave a little time for the highest altitude install prize. Sorry for this slide, I should have updated it, but we no longer carry the Power Protect 10 kilowatt. We do carry the 13, 18, 22, and 26 generators. These are all propane or natural gas standby generators. The commercial ones go from 30 to 200 kilowatt. Those are liquid cooled. And the 18 and 22 have what's known as NG max, where it doesn't derate on natural gas. The 26 has some form of NG max, where it doesn't derate as much as some of our competition. The 18 and 22 do have, and 26, I believe, also have what's known as non-emergency certifications. So if you are doing these in an off-grid install and you have it paired up with an energy storage system, we do honor the warranty for the systems. But today's topic is cold weather and harsh environments as well. I'm going to focus on cold weather on the generator. So the generator has a battery itself. It's a starting battery to be able to start the generator. And the starting batteries in these systems, if you're going to be above 30 degrees Fahrenheit, use a group 26 or group 51 starting battery. If you're going to be in below 30 degrees Fahrenheit, we're going to do a group 24, right? And the CCA is the cold cranking amps. So if we're above 30 degrees Fahrenheit, kind of, think of it as like if your nights get below 30 degrees Fahrenheit on a regular basis, I'm out here in Humboldt, California, and very rarely does it get below 30 degrees, even at night, even in the dead of winter. So I probably wouldn't need to leverage some of these, but if I'm up on the Trinity Alps or up by Mount Shasta in higher elevations, or just inland a little further, I'm pretty close to the coast, I would probably want to leverage some of these cold weather accessories for the generators. What they are is the oil warmer kit, right? That's going to keep the kind of the crankcase and the oil in that generator warm. If we're going to be below 30 degrees, although we still have that cold weather kind of, or that battery that has more cold cranking amps, we're still going to want to put in our battery warmer. And then additionally, we want to make sure that we have that fuel regulator heater so our fuel doesn't freeze up as well. And another kind of concept is these are propane generators and natural gas, but when we're operating on propane, it's not liquid propane that we're running the generators on, it's vapor. And we have these propane tanks and we need the propane to boil and create vapor. And it needs to be warm enough to do that. When propane tanks get too cold, we're not getting that vaporization and it can starve the generator of fuel. So there's a few ways to do this. One, you can bury the tank, you see in the bottom left, but there's also these tank heaters, right? We can wrap the tank in a heater and keep it warm, right? It has a thermostat, so we're not just cooking this tank the whole time. And the temperature at which you should start doing this is a little harder to quantify. What I mean by that is the amount of vaporization is going to be dependent on, one, how large the tank is, right? If you have a 1,000-gallon tank, it's going to be a lot more vapor than a 250-gallon tank. It's also going to be dependent on how full the tank is. If we have kind of a half full tank where there's a lot of surface area for vaporization, the tank is getting full or 80%, there's less kind of surface area for vaporization. I'd also say the size of the generator, whether it's a 26 or a 13, is going to require a different amount of vapor to run itself properly. And then the last variable, I guess, would also be the ambient temperature. So we have other trainings that go deeper into this topic, especially on fuel sizing as well. But just keep this in mind as a concept as we go forward. So put in any last questions you may have. Just thinking about, Briggs & Stratton and our products, right? What I'm really excited about is how easy, especially that 6.6 stacking battery is to install. I've done it in about half an hour to install the inverter. What takes time really is the conduit, pulling the wires, waiting around for the inspector to sign off on your system. We definitely have apps available. Energy Track, which we just relaunched, our new version of Energy Track, is able to do a lot of monitoring. In addition to the monitoring you're going to get through the SolarArc, my SolarArc, and the EG4 app. I think our brand matters. I showed that picture at the beginning of the talk. Briggs & Stratton has been around for a long time. We're a relatively known household name. I went to RE Plus, and I didn't recognize half the names in that hall. Briggs & Stratton is a trusted American name, and it's trusted also with the ability for our world-class capabilities. We have engineering and factories all around the world, but we specifically have factories here in the United States with engineers in the United States as well. Excited about the EG4 partnership. Still definitely excited about SolarArc. Solus and Mega Revo are a couple other inverters coming online as well. If you want to know more, especially about generator cold weather mitigation, please consider joining our Power Academy. There is more content for energy storage being put up there very soon. Not only is there e-learning self-paced course, but there's in-person courses all around the country. We also have live sessions as well. I would invite you, if you're an installer, if you haven't done your first install, if you do an install, we'll give you $1,000 off your first install with the Simplify system 6.6. If you do a system, I would invite you to join our IQ program, where we're going to give you $100 back on every battery you purchase, $500 on your second install, as well as some of the other benefits that you see down in the left-hand corner. So NABCEP, if you're here for NABCEP, email me, energystoragetraining@basco.com, energystoragetraining@BASCO, that's BriggsandStrattonCompany.com. I'll be sure to get you your NABCEP credits after I check the log as well. So let's check in who's going to get a Lego kit for the install. So Tim says 14,000 feet on Mount Evans. That's pretty incredible, Tim. I'll make sure I email you. Jedediah says, I am doing an install at 8,240 feet in Incline Village, Nevada. So that's up by Lake Tahoe, I believe. So what we'll do is, Tim wins, but we'll go ahead and send both of you guys one. If you come out to NABCEP pre-event party, I'll make sure anybody who attends also gets either a Lego kit or some other gloves, hats, something as well. Let's see if there's any other questions. Yeah, somebody's asking about install manual. The wiring diagrams for the inverter with the batteries need a little work. I'll make sure we get those updated, and thanks for any feedback people can offer. Thank you, everyone. Again, if you need NABCEPs, energy storage training at briggsandstratton.com. See you next time.